Hi there, and welcome to Pass Marathon Linux Edition. We're excited you could join us today for Denzil Ribero's session, SQL Server on Linux, DBA focused lessons from early deployments. This is session number 4 in the Pass Marathon Linux Edition, which consists of 7 consecutive live webinars delivered by expert volunteer speakers from around the community. The sessions will be recorded and posted online after the event. You'll receive an email letting you know when the recordings are available. My name is Eric Peterson. I'm your moderator today. You may know me from Pago Utilities here in Atlanta, or speaking at the PASS SQL Idol in PASS. I have a few introductory slides before I hand over the reins to Denzil. All right, the first one is if you want to zoom in, you can do that. And if you require technical assistance, please type your question into the question pane located on the right side, and someone will assist you. The question pane is also where you may ask questions throughout the presentation. I'll be monitoring this throughout there. Feel free to enter your questions at any time, and at the end we'll provide some Q&A. You can zoom in on the content by using the zoom button located on top of the presentation window. Note there will be a short evaluation at the end of the session, and your feedback is very important to us. So take a moment to complete it, and it will appear in your web browser. We want to thank our presenting sponsors, SUSE, for their continued support of our event. With their help, PASS is able to provide another exciting virtual conference. SUSE and Microsoft have been working together for over 10 years. And over the past year, they've really worked closely with Microsoft to bring the SQL Server 2017 Linux environment to SUSE Linux Enterprise. PASS also wants to let you know about the PASS Career Center. You can connect with your dream job or opportunity. Utilize this resource to review your posted jobs, create applications, or post anonymous resumes, and more. Connect with worldwide with network employees by looking at the web address listed on there, or pass.org into Google, followed by careers, and it'll bring up that listing.
And so
the next thing is, so I want to introduce Dennis Riberio. Dennis is based in Dallas and is currently speaking to us from Seattle. Denzil is a principal program manager in the SQL CAT team. He is a certified SQL master and has 15 years of experience working with large SQL Server implementations. Without further ado, here is Denzil Riberio with SQL Server Linux DBA focused lessons from early deployments. All yours, Denzil.
Thank you, Eric. Appreciate it. Welcome, folks. Thank you for taking the time. It's been exciting bringing SQL Server on Linux. Today we'll go through a few DBA-focused scenarios, and with regards to installation, configuration, we'll breeze through some installation and look at some troubleshooting-related aspects. We'll look at performance and some best practices surrounding performance. We'll also look at some advanced troubleshooting, dumps and stacks and so on, and some HA-related features. So from an installation configuration guide, I'm not going to take a ton of time on this. There are other sessions that cover some of the basics. So there's install, offline install, unattended install, and multi-instancing with Docker. The installation experience is actually a key feature. It's extremely simple. We'll walk through. One thing I want to highlight here is the unattended install. There's a GitHub project there which makes it relatively simple. Configure a conf file, and it does not only the install but some post-install configurations on the SQL Server adhering to some best practices. So as far as packages and layouts go, the installation on Linux is a little different than is on Windows. As far as packages go, a couple things are important. What repo that is configured depends on what bits you get. So that there are separate repos for for RTM and CU or cumulative updates, as well as there's a different repo for hotfix builds if you require some on-demand hotfix. The packages are broken down into SQL Server, Agent, Full Text, HA, and SSIS. And your folder structures effectively are OPT MS SQL and var opt MS SQL for your data and logs. Now the files, if you're used to Windows, we have a bunch of binaries in the bin folder, and they're DLLs and XCs and so on and so forth. On Linux, you don't see all that. All these files are bundled into something called SFPs, or single file packages, and you literally see just a handful of files with the label .sfp. These are packaged files which internally include the binaries. I'm not going to go to architecture. We're going to look at more practical examples of using this. So next is data drives, databases, and permissions, and this is an important aspect in terms of troubleshooting. When we install SQL Server, by default we create an MS SQL group and an MS SQL user. And all the files are ACLed by this user and group. So it's important when you mount a drive that folder you mount on has permissions for MS SQL. It's important when you restore a database. It's important when you use things like bulk insert of a file that it resides in a folder that MS SQL has access to. If access isn't there, you'll either not be able to see these files, or in certain cases SQL Server won't even start up. So that's one thing. The other thing, from a paths perspective, we support both native Linux paths as well as Windows style paths for easy portability of your scripts. If you use Windows style paths, C: maps to the root on the Linux file system. And as far as data and log files go, there are configurations that control that. The only thing is in-memory OLTP DLLs are still generated under default path. That's one thing. The other thing is, things like rebuilding system databases and moving system databases might be a little different in certain cases than Windows. So rebuilding system databases is done by invoking the setup, if you will. SQL Server -c setup, force setup will rebuild the system databases. When is that needed? That's effectively if you lose master, or master is corrupt and you don't have a backup and you need to rebuild the system databases and you have just the user databases. New in CTP2 is ability to move master as well. Prior to CTP2, you could move, from a system databases perspective, you could move TempDB, MSDB, and model. And the way to move them is absolutely the same as it is on Windows, with alter database, add or modify file, depending on if you want to add an additional TempDB file, or move any of the other system databases. Some of the troubleshooting aspects related to this. Since the process structure is such that we have two processes, we have a monitor process and the actual executable, there aren't separate processes for SQL Agent or FTS. So if you install SQL Server Agent or FTS, and if there's a startup issue that exists due to whatever reason, you cannot stop just the agent or the full text process. You have to stop SQL Server. So the way around it right now, the only way around it is uninstalling agent if you can't fix an issue and you still need the engine to be started up. That's one thing to keep in mind. The other thing is there isn't tight version enforcement between the different packages. As we talked about, install for agent is separate than install for server. There isn't strict version enforcement. There are minimum versions that are enforced, but so the onus does fall on you to some extent as you're upgrading, to make sure that you upgrade the various pieces together to be on the same version. SQL Server can be started up from the command line just like Windows. When would you use this? Effectively, if the server is not starting as a service and you want to troubleshoot some startup issue, you would start it from the command line, and we'll see a demo of that. So be careful to start it under the context of MS SQL account. If not, subsequent attempts, as we'll see in the demo, can fail to start because depending on who you start SQL Server as, some of the log files may be created as that user, and then SQL won't have access to do things with those files. Rollback to previous version, it's relatively simple if the database versions are not changed. So if the database actually doesn't go to a version upgrade, the rollback is as simple as uninstall the binaries and install the binaries, and it'll automatically pick up the databases as long as the versions are not changed. If the versions are changed, then the rollback includes restore from backup. And some log folders here for your reference. From a configuration perspective, it's a little bit different than is on Windows. There is no configuration manager. We bank on MS SQL Conf to do a bunch of things like enabling trace flags, setting ports, any of it encryption related or security related configurations such as certs and key tabs, for collation, agents, so on and so forth. And the settings once you do them, they're just a flat file mssql.conf which has those actual settings. Some Docker best practices before we go to a demo. Multi-instancing today is not native. It's only via containers. Of course, you want to have persistent storage for containers, whether it's a mounted volume on the host or mount a container volume, or you can take advantage of Docker storage plugins. One important command line option to the Docker run command, which we'll see in a second, is the cap add sysptrace. And that enables a debug process to connect to SQL if it has to, in case of an exception, to actually take a dump. So on, if you run into an issue where a dump needs to be taken, unless you have this option, the debugger won't be able to connect to actually take a dump, and you won't be able to get to root cause effectively. And then on the container, side of the house, the container orchestration platforms that are supported are Kubernetes and OpenShift. Effectively, container HA can be done in a way with Kubernetes using, configuring them as, two replicas as stateful sets with a persistent volume. It's beyond the scope of this presentation in terms of, going through the whole Kubernetes setup, if you will. And then, whether it's, for containers or not, or unattended install, environment variables are used for most of the config options prior to setup or when running the Docker run command to configure things like default data directory or log directory or any of that. And then last but not the least, there's an example if you want to configure a custom Docker image where you need maybe only engine and agent and full text but not something else. You can feel free to roll your own custom Docker image. So let's walk through a demo given this. So first thing we'll look at is a quick unattended install. So I'm going to go and launch this unattended install while we actually look at what this does. So I'm installing from scratch, and this is the GitHub project that I have as a link. So this is a wrapper that I've done again, on top of the unattended install procedure, which has a configuration file. So if I go to vi SQL unattended.conf, made it easy to do this. This works with all the supported Linux distributions. So the first step the conf file has is the location to the repos. So here's your 2017 repo, for RHEL or Ubuntu or SLES. Then it has a bunch of configurations which could have been passed as environment variables in an easy to use way. So you have the password, the PID, if you will, the data and log directory and the dump directory. I just realized CU2 has enabled us to even move the master and system databases. I've not incorporated that in this, but I will actually make a few changes and push it out maybe by the end of the week. And then you have things like collation, LCID, memory limit, and then you have the ability to actually install agent and full text search, so on and so forth. Besides the default config options, the other thing it does is gives you ability to do some post-install configuration. So one of the things we introduced with 2016 was the smart tempdb setup, where we detected number of CPUs and actually created a number of tempdb files. So this gives you a little of that functionality as well, in terms of it detects the CPUs and creates 8 tempdb files, or less if there are less CPUs. And then you can even have a post-install script if you want a custom post-install script. So that's effectively the conf file. And running it, you will see it's the setup is done while I was going through that conf file. So it downloaded the package. It went through the installation of SQL Server. That's the installation of SQL Server. Then it configured the SQL Server, which is otherwise a second step to install if you're manually installed. Then it configured the parameters such as PID and all those other environment variables that we gave. Then it installed agent, right? And then it did the post-install instructions, like it added the firewall rule. It restarted SQL Server, it connected to that instance and did the tempdb configuration, so on and so forth. So at this point, you should have a running SQL Server system CTL. This is running, so you have the monitor process and the actual SQL Server process, and you can connect to it, just fine SQL CMD. So I'm not going to go through connection. It's running and it's working. So that's one aspect of it. The second aspect of it, I'm just going to stop this system CTL stop MS SQL. Okay, so while it's stopping, the second aspect of it we're going to look at is the Docker run command. So vim run instances.sh. I put it in a shell script. So here I want multi-instances. The couple of things to look out in this command line. Here I have my volume mapping. So I'm saying I mounted a Docker data 1 a disk, if you will, and I'm mapping it to var optms SQL. So everything under that will be on persistent storage. Then I have the host name, I set the container name, and I add that cap at systrace, and then I give it the image I want to install from, which is the latest one. So it'll pull CU2 at this point. And simply, so I have two instances. I have Docker 1 and Docker 2. And each of them is running on a different port. So this is the port mapping. So I'm saying 1444 to the host maps to 1433 within the container, and 1445 similarly maps to 1433. So I do that /run instances.sh, and you should be able to see two instances now, Docker PS minus A. It shows me I have two containers running. One is on 1445 and one is on 1444, and they are SQL Docker 1 and SQL Docker 2. So SQL CMD minus U minus S local host comma 1444 minus USA minus P. I think it was my strong password. And select at server name should give me SQL Docker 1. So that's containers in a nutshell. So that's so we have multi instances from that. So Docker stop SQL Docker 1. And one more thing is, since we did the persistent volume, mapped the host volume to the container itself, you will see that CD under MNT. Even from the host itself, you can see Docker data 1 and Docker data 2, CD Docker data 1. You have the data, CD data. You have your MDF and LDF files, there, which are persistent across the restart. And then you can SSH into the container if you want. So let's look at one more thing, CD/var opt mssql/bin. Say I'm troubleshooting a startup issue. And I go to the bin directory and I do a start of SQL Server. it was not starting up as a service, say, I can start it up as an application. You get the error log and you're able to connect to it, and you can, diagnose any issues with startup as a service by starting this up, like this. But if you do this, what happens is, say I troubleshoot it, I make it start it up, I notice that it starts up as an application, fine. Now I want to go back and start it up as a service. So system CTL start MS SQL server. What I'm going to see here is status MS SQL server is that right now the instance is just stuck at starting up database engine, right? So if I try to connect to it, SQL CMD -s localhost -USA, you're seeing that connection cannot be made and the instance is not starting. So normal thing is I'm going to go try look at the logs. So cd var opt mssql/logs, and I see the error log here. Cat of error log to see what's my startup problem, and I see, well, there was nothing really started up at this time. If I look at the time now, it's 22 something. The last thing was the stop of the engine, right? And this is where I was talking about permissions. If you see error log here, since I started the application as a root user, is permission to root. So when SQL Server starts, the first thing it does is try to cycle the error log, and the MS SQL account doesn't have permissions over this to actually cycle the error log. So what do you do in this case? You can change the ownership back. So chmod -r MS SQL. So we'll give the group -r/var opt/MS SQL. So I'm just going after, sorry, it's not chmod, chon it is. I'm changing the ownership to MS SQL, and now system CTL stop MS SQL server and system CTL start MS SQL server should show you, effectively that this service is running. So it's back up and running. So permissions do play a role in this, and you could have looked at the var log and other folder log files to figure that out as well. So let's move on. Performance troubleshooting. The performance troubleshooting methodology is pretty much the same. As on Windows, from a core engine perspective, you can use your normal tools. The procedure of actually identifying top resource consumers or weights is the same. You use the weights and queues methodology just like you would. And identify queries that are contributing to that primary weight. So SQL tools that still work are Query Store, DMVs, Activity Monitor, Extended Events, and some of the external monitoring tools that collect SQL-specific data still just work. Now, what is different is more of the Linux monitoring tools. So from a Linux perspective, of course, if you're familiar with Linux or know Linux, then all your top and htop, iostat, memstat still work. There's a slew of tools collecting information, and monitoring tools like CollectD or Nagios or Telegraph can be used as well to, monitor troubleshoot performance at the OS, level. So we'll look at some configuration best practices around performance, and then we'll go and look at some monitoring tools as well. So in the best practices perspective, one of the common things we do with SQL Server is before we deploy it into production, we generally do at least the IO stack we kind of validate, right? And there are two things from a validation perspective. One is performance and the other is correctness. Generally on Windows perspective, from a performance, we use disk PD, and for correctness, we use SQL IOSIM. SQL IOSIM is not yet there on Linux, so it's not yet published on Linux. And there are plans to bring that to the platform, but not at this time. But from an IO perf perspective, you can use FIO or DD or IOmeter to test patterns and test multiple patterns, test sync, async, test read, write, and toggle the IO sizes depending on your type of workload. So here's a sample command with FIO. What you want to do, a couple things to be careful. If you don't do random reads and writes, you might be serving things from cache, so be careful about that, but those are things that can be done. And the other thing is instant file init used to be require a privilege on the Windows side. On the Linux side, it is on by default. Other best practices around mounting drives. When you're mounting drives is to mount with no at time in etcfs tab. And then on the OS side of the house, there are a bunch of settings that can improve performance, and we'll see a demo of that. So if you're using Red Hat Linux, Tuned ADM has a bunch of performance profiles which encapsulate some of the core OS settings. We recommend the throughput performance profile, but whether it's on Ubuntu or SLES, you can still configure the individual settings such as VM swappiness or background, VM dirty ratio, so on and so forth, to the same settings to get that performance boost, if you will. Power management is a big one, and power management not only at the BIOS level should be set to highest, high performance, but even from the OS level, C state and P state needs to be set. And the link which I've attached does have some of the details around these, best practices. Another big one is auto NUMA balancing is enabled by default on a box that has NUMA. That enables the OS to actually migrate a thread from one NUMA node to another and its associated memory. From a SQL Server perspective, we are a NUMA aware application, so we do allocations based on the number of NUMA nodes so that we maintain an memory locality. So we don't want the OS to actually move things around because we've allocated with a purpose. So our recommendation is to disable that. And then on larger boxes with a lot of memory, there's the default max map count, which is the amount of blocks, or it's a map of how many memory allocations you can make, is set to 65K. We recommend to change that to 4 times that effectively with, you can use sysctl to do that, or directly write it into the corresponding file. So those are individual settings. So we'll see this in action in a second, but for folks who don't have a monitoring system from the OS side on Linux, we have a blog post where we've put out a sample with collectd and Grafana to front end this. So each SQL Server instance effectively will have to pull a Docker container which has collectd, and that pushes SQL monitoring, OS and SQL monitoring data into a central server which will host InfluxDB, which is an open source time series database, and it's front-ended by Grafana as a dashboard. And the blog has details of kind of how to set up and configure this solution, if you will. So let's go to one more slide, and actually I should have I had the slides in order. From a SQL best practices, so we talked about OS best practices and some of the monitoring. For a SQL best practices perspective, affinitizing CPUs is something we recommend. It can give you a 5% performance boost is what we've seen in certain cases, even 10%. And this is on bare metal. So if it's on VMs and all, I won't worry about it. This is on bare metal that we've been able to squeeze that extra performance boost. tempdb config is post installation, so be aware of that. And so if you have tempdb latch contention, creating multiple files is important. The other big part is memory. Memory by default, Linux only sees 80% of the memory visible to the box. So SQL sees only 80% of the memory visible to the box. And so it's okay if you have 64 gigs or 32 gigs of memory to do that. Once you go into the 128 or half a terabyte or terabyte of RAM, 80% means you're wasting a fair amount of memory. So MS SQL Conf actually does have throttles or a configuration called MS SQL memory limit MB, where you can raise that number to something more reasonable. So on a 1 terabyte box, you can even go to 95% of the memory, whereas on a smaller box, you won't want to go that close. You need to keep at least 4 or 5 gigs for the OS, on a decent sized box like 64 gigs or something. And then be aware of killer, settings on the OS. So here is there's a fix with regards to how we actually allocate schedulers, which can hurt performance. That's already fixed. So if you're an RTM, you might want to upgrade to get that fix. So let's look at the demo of the perf side of the house. So the first thing I'm going to do is run up a particular workload and show you the dashboard and the configurations associated with it. Okay. So 30. Okay. So this is the front end of that Grafana dashboard I was talking about. So there are two parts of this. Once you get this actually installed, you have a central place to monitor all your servers. You'll get a drop down with the servers that are configured. So in this case, I'm looking at this particular server, and here are a set of reports. So there's a core SQL metrics, there's a core server metrics, and these are some custom reports which I had. So from a core server metrics perspective, you have your usual culprits, the CPU, memory usage, so on and so forth. Then you have the process memory. So you see, and you can slice and dice, relatively easy into any of these, counters. You have the memory consumed by SQL Server process itself. Then the next set of counters have to do with, disks. So you have the write and the read, and you have, latency, throughput, and IOPS. So those are the three things that you see. So you average the seconds per, disks per second, bytes per second, and writes per second. So that's IOPS, throughput and latency, and for the read and write aspect. And then the last but not the least, you have network, throughput and free space. Free space is less interesting, if you will. And then the other dashboard is effectively, the SQL metrics, if you will. So you have transactions per second, you have batch requests per second, and you have, the weights, if you will, on the system. So let's look at, one thing, tuned ADM. I did a mistake. Okay, so you have the throughput, performance profile right now. You have an average of about 65K batch requests per second. So that's the recommended, profile, if you will. But if you go to a Red Hat box and install tuned ADM, you have a set of profiles that can be configured. And the default is actually configured as balanced. It's not throughput performance, right? So it's a generalized, tune profile, if you will. But you have a choice between, latency performance, network latency, so on and so forth. What we suggest is throughput performance. Okay, so we saw that it's about 65K. So I'm going to change this on the fly to be profile balanced. And you will see, or you should see, hopefully, that throughput, it'll take about 30 seconds, maybe 5-10 seconds to drop. But you see that the throughput is already dropping to 61K, right? So if you look at this, number, it's already dropping, based on the profile. So profiles are important from that perspective, and the profile is nothing. Tuned ADM just makes it easy to encapsulate the other settings. So it's not Red Hat specific. You can have the same set of options applied to any Linux distribution, if you will. So that's this demo. The other thing looking at actually how this is done. Let's go to the cd/home/administrator. So the way is SQL Server Perf monitoring. You pull down a GitHub repo, and you have an image for collectd. You have an image for collectd, Grafana, and InfluxDB. On the SQL Server, you have to run the collect DB image. So cd collect d, and it's nothing but modifying a few parameters, such as what's the port of the InfluxDB, which is the default port is fine. What's the source name? What's the credentials you're going to actually connect with? And then it will actually pull down the image and start the image for you. So if you look at the SQL Server instance itself, docker ps -a, you have the collect D container, so you need to run Docker, of course, on the SQL Server. Similarly, if you go to the central box, it's a pull of the Grafana and InfluxDB image, where you just change a couple run.sh parameters, and the blog has more details, about that. So yeah, that's that. So the other parts of the SQL report are the weight statistics. So you have weight statistics, you've got your memory blockers and clerks, you got database activity, and then you have connections and logins, logouts, and a couple other details around that. So feel free to explore, and if there's something that's missing. And I know a few folks are using Telegraph, and so Telegraph does has a solution for SQL Server too. We just found it this very lightweight when we were testing in the lab. So that's that. Let's move on to the next topic. So a couple repeated issues that we've seen: bulk load from JDBC. So given SQL Server on Linux, now you have a new slew of apps that come into the picture, whether it's Spark or whether it's Java apps. On the warehouse side, many of those use either Spark data frame write, or from a Java they use an execute batch, which Spark data frame write actually uses under the covers. And so while this execute batch sounds like it's a bulk upload, it's effectively a batch, a set of prepared statements. It's not actually using any of the bulk API. So in particular on the data warehouse side, we've seen several times already that when using this API and going to a column store table, this lands, because it's a bulk it's a set of singleton inserts. It lands in the data store, in the Delta store, and your perf of data load effectively goes down. So it's often mistaken for bulk copy. Instead, use the MS-JDBC driver with SQL Server bulk copy if loading lots of data. And here's a sample from actually a customer workload we did, with the execute batch versus SQL bulk copy. The difference is, the graph is time in seconds. It's day and night. We got some 8x, improvement in performance. So be careful of that from an app's perspective. The other thing is, from a performance data collection perspective, if you're working with some end customers and they have a performance problem, and now you want to actually collect a set of data to analyze, we have a PSSDiag equivalent for Linux. Folks might be familiar with PSSDiag on SQL Server on Windows, which effectively collects perfmon and some other DMV scripts, and then you can use SQL Nexus, which is another tool. The links are there to analyze that information. So with Linux in the picture now, we have an equivalent for Linux. Of course, there is no perfmon to visualize it right now. The collection is just a collection in flat files. We are working on a utility to actually visualize some of that in perfmon for those who are familiar with perfmon, and also use Power BI to actually visualize the SQL counters which are collected by the DMV scripts. But SQL Nexus actually will load all the DMV scripts collected into a database, and you should be able to visualize blocking and weights and all this other stuff that you usually see with that. So I won't have a ton of time given this is a short session to actually go through the analysis piece, but I will show you what the collected piece actually looks like, and so the collected piece actually looks very similar to what on Windows looks like. So you have the machine name, instance name, and you have a set of .perf files, which are the performance metrics collected from the OS perspective. And then you have the .out files, which are DMVs. So if you look at IOStats, for example, this is IOStats from SAR, just collected at a lower granularity of 5 or 10 seconds, and the PSSDI file actually has settings to say what frequency you want to collect this, so on and so forth. So you have your IO, CPU, all your common resources on Linux being collected. So let's move on, because I have a couple other bigger demos. Let's look at advanced troubleshooting, and not so much from the dumps perspective as much as what do you do if you face a hang. I'm going to go into level 400 or 500 dump analysis or anything of that sort. So SQL dumper.exe, you should be familiar if you're using SQL Server, which effectively on an exception takes a dump, whether it's access violation or if it's a scheduler non-yield, a dump is generated. That dump is a Windows PE format dump, so it can be understood by WinDBG. Besides that, there's also a Linux native dump called a core dump. So the reason I'm bringing this up is if you cannot connect to SQL Server, and for whatever reason SQL Server is not accepting connections, if you want root cause, you should at least generate this manual core dump, so that post-analysis can be done if you're in that state ever, right? So the code dump generation command is below, and that's the key one in terms of if you're not able to connect and you want RCA, because now it's not only the SQL Server engine, there's also the PAL layer on top of us, right? So it takes a dump of everything. So that's one thing. The other thing is extended events and symbolization of stacks. So on Windows, it was easy to get public symbols and drop a PDB and symbolize a call stack. Why do you need that? Let's look at it actually from an example perspective instead of talking to theory. So let's go to another demo. So I have a so this is effectively a scenario where there is a script which was running. It was a move from Windows, or comparison between Windows and Linux, and there was a script that was running in X seconds on Windows and was taking much longer on Linux. And so how do I try to figure out the why? So I'm going to go ahead and drop this database. I should have done that before. Messed up. And then create this database. So I'm creating a brand new database. If it finishes, I hope somebody else doesn't have a lock on this thing. Okay, yeah, it rolled back. Somebody probably had I had another connection going on to it. So I just create a new database here. And then I'm going to start a couple extended event sessions, and we will see why in a second. And so I'm running this script, and it doesn't really matter what the script is. In this case, it's a bunch of memory optimized tables that need to be compiled, so on and so forth. So it's a script, but it could be anything, right? So let's say you have a process which is, running a little slower. So I'm going to run that. And then, I expected it to be a couple of seconds. So I'm running, trying to see what is running. I'm not seeing a ton. You see the script running here. It says status is suspended. So the next thing I do is actually I go through my wait stat analysis. So let's go through wait stat analysis. Let me watch live data just because I want to show you a couple of things here. Okay, so I go through wait stat analysis. I take one snapshot of wait. Okay, I'm not seeing a ton. I take another snapshot of wait, and during this 15-second sample here, and this is waits and queues, methodology of analyzing performance. I'm seeing a couple, waits which look, vaguely, different than anything I've seen on Windows, right? They're a preemptive class of waits. And preemptive generally means you're off the scheduler, so you're not blocking any SQL request per se, but it's an API call, generally speaking, that is taking longer. And so in this case, we see that it's preemptive OS create directory and preemptive OS delete file. And we can run that again. I don't think it's already done by this point. So it took 48 seconds, right? But these preemptive things are not something we generally focus on the Windows side, because we assume an API call will be really quick and it'll be done and it won't affect things. This is where on the Linux side, you can see some differences, and also you would want to monitor preemptive waits. Okay, and so if you look at the wait info extended event itself, and we'll see that. So the other thing I did was, okay, I knew this was a bunch of compiles of memory optimized table. So I ran an extended event, and what I have in the extended event is nothing but, if it comes up soon, is nothing but couple of the compilation related events. So I have statement started completing. I have wait info here to see what waits, because we saw those preemptive waits. I filtered on the preemptive waits, and actually this two waits, if you see, wait info and wait info external. Wait info external is the one that looks at preemptive. Wait info is non-preemptive waits. So when you're defining an extended event session, be aware of that, and don't ignore wait info for external. And then I have the other compilation stage. And so I wanted to prove, well, is that really a problem in terms of waits? And then I see for this one statement, it was session ID 66. Let me stop this XC, otherwise it'll keep scrolling. It was session ID 61, and I see that for every, it seems like it's going in a loop, and there's a create procedure here, right? 61. The next row of 61 is here, and if you look for every create procedure, which is this create procedure, you see a wait on preemptive OS create directory and another wait on OS create directory, and it's 174 milliseconds and another 162 milliseconds, and this keeps going on and on. And there's a preemptive OS delete file again, and if you scroll up and down this thing, this pattern keeps repeating. So it's a script that was doing a bunch of things, but this pattern keeps repeating and adding up to kind of the time, if you will, right? So how do I get any additional info? And generally on the Windows side at this point, I would collect a call stack and analyze that, or try to figure out from the knowledge base article if it's a known issue, if there's a fix, so on and so forth. So the way to do that in Linux is, so you can do the same thing on the Linux, except the symbols aren't there, and that's where that call stack resolver comes useful. So I'm just going to read that extended event, right? And I read the so what I did is create another. Apologies, I created another extended event on that wait, since we determined that wait was our problem child, right? So it's wait info external, and I filtered it on preemptive OS create directory, right? So this is the preemptive OS create directory, and as an action, I collected the call stack because I wanted to know, what within the engine actually was, happening. Why was it waiting on a create directory, which sounds, pretty weird. So, so you get that call stack, which is, and the target was a histogram, so it's bucketized on the call stack. And so if you look at the histogram itself, you see that this slot count was, 10, or there were 10 calls into this particular call stack, right? And there were another 10 calls, and there were just 10 tables I was creating in this case. So it seems like for each of the table creation, it went through this call stack, then it went through the second call stack, and it doesn't make sense like that. So XC call stack resolver is very helpful. So I just copied and pasted that call stack here, and the link in the deck will points you to a GitHub page. So you can download public symbols and actually get a symbolized call stack for that. And this, you can use this even on Windows, not only on Linux. And resolving the call stack, you see, well, this is a create of a hackathon table, which is calling some get database code generate directory, which is creating and ACLing a directory. Right, so that helped us identify, well, it's during ACLs of a directory, and look at source code to come up actually with a fix. And this issue is actually fixed in CU2, and the fix is, so we've come up with the fast compile path, which now fixes this issue. So if I go back and enable, in this case, trace flag sudo su, let me zoom in. If I enable trace flag 9944 and I restart SQL system ctl restart MS SQL server, just give it a second to start, and then I rerun my repro that was there. It's not this one. I will rerun my repro, which I'll have to delete the database. Again, this should be relatively quick in comparison. It was 48 seconds before that. Create the database. And, oops, sorry, I lost control of my mouse. Apologies. And I run that script again. Hopefully I have the fix bill. Yeah, it's 5.4 seconds against 48 odd seconds. Right, same script. So don't. Moral of story is probably don't ignore your preemptive waits, if you will. And look at the call stack resolver with the link of GitHub if you want to get call stacks for bucketized waits or spin lock contention. You can use it in a variety of ways. As you see bottlenecks creep up. So last but not the least, we have availability groups on Linux, which is the HA solution. We have two types. We have the cluster type equal to external, which is an external clustering solution with pacemaker. So HA effectively needs some sort of cluster. There isn't Windows cluster on Linux. So what we've gone on for now is with pacemaker. Now note that on the release version, we required 3 sync replicas for HA because there was nothing like a file share witness per se. So you needed a third copy of the database and hardware enough to handle a third copy of the database, and the potential performance overhead of a sync commit to yet another replica because it had to be synchronized in order to fail over. We identified them midway into the cycle based on feedback and customer stuff that it was both a licensing requirement and cost for hardware. So there were changes made in CU1 to allow HA with 2 sync replicas, and there's a concept of configuration only third replica, if you will, which can be run under Express Edition. So we'll look at that in a second. Another thing to be very clear on in terms of production support for a cluster type external is that it requires Stoneit support, and Stoneit, or shoot the other node in the head, is the full form is there's fencing agents which effectively monitor the state of nodes and either remove them from cluster membership or shut them out or take action. So pacemaker cluster is only supported if there's a Stoneit agent available, and there are limitations currently on cloud platforms for HA because Red Hat, for example, there's no certified Stoneit agent right now for Azure on RHEL or Ubuntu. So some samples of Stoneit are there on GitHub. These also can be hardware dependent. So on a bare metal, you might use an ILO agent versus on a VM. Depending on if it's VMware, you might use a different type of Stoneit agent. So we'll see that in just a second. And then there's the cluster type equal to none, which is more of DR or read scale. There's no HA component to that. Quorum is not maintained since there's no cluster components. But this is also cross-platform in terms of it can span Windows, to Linux, but that's used more as a migration thing than anything else. But cluster type equal to none can also be done with Docker containers, if you will. But for containers, for sake of completion, you can use also Kubernetes, like we talked about, with stateful sets, for some type of HA there. So let's look at a quick, demo. We've got 5 minutes left, for the HA stuff. So, first I'm going to, just view what a configured, AG looks like with the CU1 bits. So you see two synchronous replicas here. And we'll see the script in a second. So you see a primary and two secondaries, right? And two of them are synchronous commit and one is configuration only. And this is something new that was added, right? But the databases are only seen for the ones that are actually synchronous commit, because this configuration only doesn't have the database per se. It just has the metadata store to ensure quorum and things of that nature. So that's a new state. And I'm going to cheat at this point just to see. Okay, PCS state. Okay. Let me go to a failover scenario, if you will. Clear. That doesn't matter. So PCS status is what we would use to actually look at the state of the cluster on Pacemaker. You see that the cluster has 3 nodes, if you will, right? So it's O2, O3, and O4. The master currently, or the primary, is O2, and the slaves are O3 and O4, right? And so failover, the architecture also of clustering is that it's not as tightly coupled as Windows, where a failover can happen from within SQL by marking the AG as external cluster type. All actions in terms of failing over have to be done from the cluster perspective. Okay, something is not very well known is there's the dashboard UI too. If you hit any of the nodes port 2224, there's a dashboard which actually pops up more of the configuration. I don't use this. I generally use this just to view the state of the cluster. So you can see nodes, you can see resources, and the state. And I've not used this a ton to honestly do an operation, though you can. I tend to use command line more than this, but for the GUI-centric folks, there is a UI which enable you to see state of the cluster. So let's do a quick failover, here. Okay, first thing is the log. Corosync.log is one which you'll use quite a bit if you're troubleshooting any of the cluster portions. So I did a tail, just to show you the last thing. And here you see, I'm going to stop this, but you see the looks alive, connectings. So you say the state transition, you're connecting to an instance, you're querying the role, here Denzil AG, the availability group is in secondary role. So this is the pings effectively for health, right? So that's, what that is. And then we'll go ahead and fail over this, real quick. And as we are failing over, oh, it's already promoted, wrong node. So let's fail over to 3 actually. As you're failing over, CRM mon is a great way to actually see the action as, it was a master and now all 3 are slaves, and shortly you will see in a couple seconds as they resolve and bring things online that you will, have a master, come up. While this is, going on, couple of things from a StoneIt perspective, go to that GitHub link. I'm running out of time because I'm at the minute mark. One best practice I would say for the StoneIt agent is to test out, and these are all in that GitHub link, is to test out the Stoneit agent before you add it to the cluster, because once you add it to the cluster, troubleshooting why it doesn't work is tedious. So here's how you would test out Stoneit agents. So at this point, I'm going to give a minute for questions. I'm going to stop the presentation, if you will, and see if there are any outstanding questions. Eric, I was monitoring chat, so if there is anything in the queue, would love to answer that.
All right, there's a couple of questions popping up here. First one is, are tokens still available in Linux SQL? So you're able to pass tokens from agent to SQL, etc., as you can in Windows versions?
When you say tokens, I'm not quite clear what you mean by tokens.
Yeah, I was thinking the same thing. That was from David Clipsome. So if you can add a update to that, David. Another couple of great tips, comments out there. And can you post the GitHub link on the chat? Sorry, joined late.
So would they have access to the deck, Eric? It's on the deck.
Yes, the slide deck is going to be posted, and everyone's going to have a copy of the presentation. Yeah, it's going to be. You'll be able to look it up, and everyone who's on here right now is going to get an email with the information. Do we have any other questions? All right, David responded with SQL Server agent tokens. Let me see.
David, my email is denzil@microsoft.com. Please shoot me an email. I'll be happy to answer, detailed question. I probably have some clarifications around the exact scenario.
Here, I'm going to see if I can open up. David, your mic might be on. Can you talk?
Hi, good day.
Hello.
Can you hear me?
Yes, we can.
Yeah, so the agent tokens have been in since like the early versions, 6 and 7, I believe, and they're just allowed to pass information from agent to SQL behind the scenes, so you can pass variables across for listeners.
Okay.
Sometimes used for monitoring or tricking jobs and that kind of thing.
Yeah.
Just to see whether it was available in the Linux version as well.
Let me, I don't know it at the top of my head. I mean, there are certain things in agent which are fundamentally different, job subsystems being one of them, right? Not all the job subsystems are there. So I will have to get back on agent tokens, David. I don't know that at the top of my head. If you shoot me an email, just shoot me an email, I will respond.
All right, very good, everyone.
Okay, thank you.
Well, stay tuned for our next session, Linux for the SQL Server DBA with David Klee, and thank everyone for attending. It's been a great session, Denzil. I really appreciated it.
Thank you, guys. Have a great remainder of the day.